Welcome to Walkabout the Galaxy, the You're Not Being Lectured To astronomy podcast, where the science is universal, the opinions are personal, and the trivia is cinematical.
Ooh.
Mm-hmm. We are Strange, Charm, and Top, the astroquarks, also known as Josh Cole, Addie Dove, and Jim Cooney, coming to you from the Walkabout studios at the University of Central Florida. Our stumpers are planetarial.
No.
Nope.
What?
We didn't like that one.
No?
No.
Jim, dwarf planet or super Earth?
Dwarf planet
Yeah.
or super Earth?
Mm-hmm.
Those are things. Those are each things.
They are?
Yeah, in astronomy.
What?
Like in intro astronomy.
That we've talked about
in
on
like,
the podcast.
In like 101 astronomy, a course that you teach.
We've talked about them on the podcast.
He's like, oh, wait a minute. You are Jim Cooney, right?
What?
It's like, I've walked into the wrong room.
His office. I like a super Earth because why wouldn't you? Like, it's Earth, but it's super. It's better.
Yeah.
It's not
I don't think so.
better,
But also, we've found a lot of them. They should be able to harbor life if they're in the right spot.
I think super Earths are actually crappy Earths.
Crappy
Well,
Earth?
it wasn't your question.
Yeah.
No,
Yeah,
it
you
was,
don't get a question.
Was my question.
Okay, it
I
wasn't
like
your turn to
super
answer.
Earth.
My question.
Jim picked Super Earths.
All
He
right,
might have been
he's
wrong.
picking super Earth.
But
Yeah.
Well,
Or
no,
for
he
the
can
wrong
choose.
reasons.
He can choose whatever he wants to choose.
Yeah.
It's his prerogative to be incorrect
Often.
when expressing his opinion. The opinions are, as we said, personal.
Mm-hmm.
Addie,
Yes.
ice giant or hot Jupiter? We'll
Ice
find out
giant.
if you're going to run hot or cold.
Ice giant.
Cold. Ice giant.
Yeah.
Why?
Because they're so intriguing. Why are they the way they are?
So we have two ice giants in
They're
our
both
solar
intriguing.
system.
Yeah, we do.
Right.
Uranus and Neptune.
And
Followed by dwarf planet Pluto.
right.
And many other dwarf planets.
Right. And the hot Jupiters, we don't have any in our solar system.
Correct.
But there's a
there are a
gajillion out
lot
there.
in other solar systems.
Yeah.
Other exoplanetary systems. Stellar systems.
I don't know if there's necessarily a jillion.
There's
No,
a bunch.
not a jillion.
So we've found a lot, but a lot of that is observational bias. I think they're probably still
well, it's easier.
not ultra common.
It's easier to see them, but we've seen a bunch of them.
I mean, it depends on how you define a bunch, but yeah.
Well,
They are
I
more
don't-
common currently than other objects we've discovered, right? Than like super Earths, for instance. There's more hot Jupiters that we found than super Earths.
just because our observation technique allows those to be easily found doesn't guarantee that we would have seen any.
They weren't
didn't
predicted to exist,
they
right?
weren't predicted to exist.
Right.
Yeah.
Right. So it's awesome. There's way more
so-
of them than we expected, but
Right.
still
Since
probably
we expected zero.
Not a jillion.
Yeah.
Yeah.
Still
Anyway, we'll come back to this because the reason we're talking about those different plant types is there's a little bit of new news about new news that's probably repetitively redundant about exoplanets, both super earthy and ice gianty.
Yeah, I think it's just news if it's new news, but it's old news if it's old news.
That's true. That's an interesting conundrum. So we'll talk about some of that new exoplanet news. We'll touch base on some news, plain and simple news
we do.
about matter, antimatter, and a new measurement of the differences between matter and antimatter that might help explain why the universe is matter, except it doesn't really, but maybe gives us a hint about future lines of research. But first, this episode of Walkabout the Galaxy is brought to you by the Riemann hypothesis. Ever find yourself wondering what the real part of a non-trivial zero of the Riemann zeta function is? Who hasn't? If you had a nickel for every term in the zeta function, well, then you'd be infinitely rich. The Riemann hypothesis can't make you money unless you prove it, in which case you're going to get a cool $1 million. But in the meantime, take it from the Riemann hypothesis. The answer is 1/2, 0.5, 50%, 1/2. Let's see the Birch and Swinnerton-Dyer conjecture come up with an answer that easy. The Riemann hypothesis. It is, are you?
Whoa.
Wow.
Bonus trivia if you figure out what it is, are you, is the actual tagline for. This is a new thing the sponsors are doing now.
Taglines?
They're stealing.
Our
taglines
sponsors
from
are
other
stealing taglines from other
Or
things.
last time it was L'Oreal or whatever.
That's right.
Yeah.
It is, are you? I'll give you a completely unhelpful hint.
Perfect.
It's from 1987.
IBM.
I'll give you another slightly more helpful hint. It's for a newspaper.
Washington Post.
Washington Post, it is, are you? It's a Post, are you?
New York Observer.
This is getting better. Final hint, not an American newspaper.
Oh, then I don't.
I don't.
The Daily Gazette.
The Independent.
Oh.
It is, are you?
Wow.
Anyway, the Riemann hypothesis sponsored the show because some new work recently published proved for most situations a thing is true, and if that thing could be shown to be true all the time, then the Riemann hypothesis would be proven. Anyway, the Riemann hypothesis is one of these famous mathematical things where some brilliant guy in the 19th century said, I'm pretty sure this is the case. Here's a scribble in my notebook.
Right.
And then 150 years of brilliant mathematicians further on hasn't actually been proven.
Right.
Yeah.
Like the
it's true, but we
Fermat's
can't
last
show
theorem
why.
was one. And yeah, it always seems to work out that it's probably true, but it hasn't been proven. Anyway, there's $1 million out there if you can prove the Riemann hypothesis.
Get
And
to work, folks. Let's get to work.
they haven't proven it, but I liked it because it's actually fairly, as these things go in abstract, complex math, I could at least understand the statement of it, and I could understand the function. The zeta function is not a very complicated function. It's just the infinite sum of 1 over n to the s, as n goes from 1 to infinity, and s is the argument of the function.
Right.
So that's not, doesn't take a lot of space. It's like Jim's equation for general relativity. G equals 8 pi r over t.
R over T.
This has gotten
So
out of hand.
We're gonna find
the
units
Cooney
that make that
conjecture,
work.
the Cooney conjecture,
conjecture.
general relativity is 8 pi r over t. Anyway, some progress was made in that direction, and but no $1 million yet.
So I wonder if so one of the great things about mathematics, of course, mathematics is one of these funny things. Like, it's not science, but it has direct bearing on science, right? It's kind of the language that scientists use to express laws of nature. And so I wonder, I don't know enough about high-level mathematics to know if the Riemann hypothesis has physical implications or not.
I don't either. But
But
it's one of 7 big math challenges.
Right,
out
yeah. I
there.
mean, I've heard mathematicians say it's like the most important unsolved problem in math.
More important than the Birch and Swinnerton-Dyer conjecture,
I guess I've never
because
heard
that's
of that.
one of the other 6.
Okay.
One of the others, actually, on that list of 7 mathematical challenges,
Is it
grand
like the
challenges,
7 ancient
is
wonders?
is the Navier-Stokes equation was listed as one.
Wait, really?
Yeah, that
What
it's,
about it?
there's something that you mathematically, whether or not you can show that there is a solution to it in various
Well, that would probably
forms
have
or something.
significant physics
That's
That has
certain-
physics implications, yeah.
For me as a dumb, working
Dumb physicist.
Navier-Stokes equation is like, these are the equations to describe the fluid flow.
Yeah.
And
here they are.
There they are, and sort of I crank
Use
through
them
them
to
without
solve things.
thinking about anything else. But apparently there's something deeply mysterious underlying the Navier-Stokes equation that I
Interesting.
had been previously completely unaware of. Maybe I'll reach out to them and see if they can sponsor the episode.
Great. We can learn a little bit more about them.
Cool. Lots of space news going on.
Always.
We
Constant barrage of space news right now.
Right. So we mentioned previously the launch of the SpaceX first salvo of SpaceX's Starlink
Yeah.
global internet communication satellites.
But all the internet's been a Twitter
Yeah.
about it.
Why?
Because it's a little bit, it's a lot of satellites. And so astronomers are freaking out a little bit.
Well, they were like, oh, hey, guess what? You can go outside and see these satellites as they're inching up to their higher orbit, because they were initially deployed at relatively low and bright enough that if you had a dark sky, you could see them. And some people were taking cool pictures of these 60
Yeah, it's pretty cool.
dots of
Which
light.
sounds cool, unless you're an astronomer trying to see something in that area.
Yes.
Yeah, I don't know. Is it really that big a deal? Because if you're an astronomer, you're looking at something in a specific direction, usually for a long period of time. That thing's just going to go zipping by.
Yeah,
Yeah,
but what if you're leaving the exposure open on your thing and the thing zips through your exposure?
Yeah.
Saturates your
It's also
exposure.
like this was 60 or whatever, right? But the whole
There's
thing
gonna-
is that they're planning on doing 25,000 or something, and
Yeah.
then they basically fill the sky. Like, so there were some people that were calculating there will be more than the average number in your sky. There will be more than the average number of stars above like fifth magnitude or something that are like typically visible, right? So like, but it's also, and they were brighter than they were supposed to be. But I think part of that was they weren't in their correct orbits and their solar panels weren't facing the sun.
Did they paint them black?
I don't think so.
Because that would help.
Yeah, I mean, they could use carbon black, right?
Right.
Yeah,
I mean, it
like
actually
absorbs light. Yeah.
actually would help. You can make these things less reflective if you
if you
make
need
that
to.
a priority.
Carbon black's a little complicated on spacecraft surfaces. It can lead to some crazy charging effects, I think, but because it's got a lot of structure. It's not a flat surface. It tends to be a
little bit
a
fractally,
textured-
spiky forest of molecules or atoms. So that's
I don't know
going
if they
on.
I don't know. Maybe the Department of Defense covers all their spacecraft in that. We don't know.
Our colleague and friend of the pod, Phil Metzger, posted a tweet storm. I don't know what else
done
to
a
call
few.
them.
Yeah, about it.
One of these tweet decks of 40 or 50 tweets explaining how something like this is inevitable as the species outgrows our capacity, or the planet's capacity, to contain information.
Yeah.
And communicate that information, that we have to break free of the surly bonds of Earth.
Yeah, I mean, Starlink, in theory, will be a useful thing to bring internet to places that don't necessarily have internet, but in practice, it's going to take a long time to get to there, and like it's slow internet, and
Yeah.
so I don't know.
It'll be interesting to see how these things evolve, because the technological landscape for space commercialization, internet, data, and computation has evolved very quickly, exponentially, really. And so it's things are definitely moving very quickly in that front. But there was another big announcement from NASA today. In our last episode, you had seen Jim Bridenstine talk about the Artemis mission, which is, or the Artemis program rather, going forward to the moon with American astronauts within like the next 5.5 years.
Yep.
So that's crazy
ASAP.
fast.
Get on it.
And sort of related to that, there was an announcement today about some commercial partnering.
Yeah, so the whole thing with Artemis now, well, a lot of what they're doing now is purchasing the landers and things like that. So they've had a call out for a while, and they just announced the winners of the Commercial Lunar Payload Services, CLIPS, contracts. And so these are lunar payload services. So these aren't for humans. These are little smaller landers that are going to go to other places on the moon to start. And they're going to land, and they can take instruments, or like Astrobotic for a long time has been partnered with DHL, which is a shipping
DHL,
company.
the shipping company.
And they have this thing called Moonbox, so I think they'll take some of those, where it's like people can pay
it's a
to
DHL
have
delivery box.
DHL delivery to the moon kind of thing. Yeah. So
Does somebody have to sign for those?
Chunk?
they're not going to like spray it around. They're going to have it on the spacecraft.
What if there's nobody there to sign for it?
It probably gets returned.
Okay. So some
Astrobotic is one of them. Intuitive Machines is the other one, and Orbit Beyond. And I think Intuitive Machines is related to one of the bigger companies, the bigger, more well-known space companies.
Okay. But these are not the things, as you said, these won't be carrying astronauts. And will NASA be using the same sort of technique to determine, like, they're going to, I think Bridenstine said NASA would be essentially purchasing a landing service from
it's
a company.
Of like they're doing with suborbital flights now, and with parabolic flights, right? Like,
and also with commercial crew to ISS.
And commercial crew to ISS, right? So we, for instance, as scientists, we have an idea for an instrument or a payload, and we propose it to NASA, and NASA says, sure, this is a great science. You should do it. Here is a
chunk of money.
Here's a chunk of money, and here's money to buy a contract with Blue Origin or something like that. So they've started doing that already. They've already had calls both internally within NASA and for like universities and stuff to build instruments or payloads to go on these landers. They haven't announced those selections yet, but
And they'll be
with bated breath.
And they'll be doing that with astronauts going to the ISS. I mean, those contracts are sort of in place, but the launches haven't actually happened yet. But presumably this year in 2019, NASA will write a check to SpaceX and or Boeing, and in return, they will take NASA astronauts up to the ISS instead of NASA being sort of the operator and controller of that trip, and then they'll be doing
Roscosmos being the operator and controller of that trip as they have for 10 years.
That's right. I mean, essentially, right now we are doing NASA is doing that same mode, but instead of paying a private company, we're paying the Russian government to do that. So we'll be paying private companies to take astronauts up to the ISS, and then the idea is by the end of 2024, we'll pay some as yet to be announced private company to take an astronaut from the Gateway, which is a phone booth with solar panels orbiting the moon, or will be, from there down to the surface and back up again. But NASA would handle getting to the Gateway.
In theory, Orion will be the vehicle that takes humans from Earth to Gateway.
Right. And on a NASA booster, the
on
SLS, Space Launch System.
Yes, that's nominally
that's the plan. That's the Artemis project.
That's the Artemis
architecture, the plan of what will happen. Well, 5 years. Hopefully, we can hang on that long and see.
I mean, EM1, which is now Artemis 1, is supposed to happen this year.
Is it really? By the end of this year, and that's an uncrewed. That's just a big up and down, right?
It goes around the moon.
Artemis 1 does?
Because EM1 is the one that has a bunch of CubeSats.
All the CubeSats? Yeah. Okay, I didn't know if that was Artemis 1 or Artemis 2. Or EM2.
Sure
anyway, coming up, big, exciting rocket launches. So, let's...
coming up in the medium near future, big, giant fights about who owns the moon.
Yeah.
Yeah.
True story.
No, yeah. Sorry. Let's talk about the Forbidden Planet.
Ooh.
So, we have a couple of planet stories. And we mentioned ice giants and hot Jupiters and super Earths and dwarf planets. But we won't be talking about dwarf planets any further. And that's just a sort of arbitrary kind of BS definition that gets back to the whole Pluto business. So we'll forget about that.
Right.
For exoplanet stuff,
around the moon.
Artemis 1 is going around the moon. For exoplanets, we've seen a lot of hot Jupiters. And as the name suggests, that's a planet sort of Jovian size or bigger that is very close to the star.
It's also like a great, 40s expletive exclamation kind of thing.
Hot Jupiters! Well, I never thought of it that way, but
all right.
I might try.
Using that.
I might try using it. Yeah. So that, as we were saying earlier, we've seen a bunch of these things. We're disagreeing about exactly how many.
How many we've seen, just how many there are.
Right. How many there are in the Milky Way galaxy, for example.
Compared to other kinds of planets. Anyway, we'll move on. There are lots.
There are lots.
Greater than some, less than jillions.
I don't know if we've seen more than 1,000, but we've definitely seen... We may
Not
have
hot
seen...
Jupiters. We haven't seen more than 1,000, I don't think.
We've definitely seen many hundreds.
Yes.
In any event... they were not expected because our ideas about how our own solar system formed involved to make a big planet, you need ice. To have ice, got to be cold. So you got to be far from the star.
Right.
Obviously, planets move around after they're formed. We think that probably happened in our solar system as well. And in a lot of solar planetary systems, those big Jupiters formed where it was colder, probably, and then moved in close to the star and then stopped moving. So that's a very interesting problem in its own right. This new... discovery is about, I think, what would be called a super Earth or an ice giant.
It's a Neptune size.
Okay, so it's in the ice giant.
Yeah, like an ice gianty planet.
They don't call them ice giants though. They call them Neptune sized.
Okay.
All right.
Because ice giant has specific implications, right, about it being icy.
Right. We call sometimes Uranus and Neptune, the 7th and 8th planet giants from the sun, ice giants because they're big, but they have some significant differences from Jupiter and Saturn, which are much more gassy than Uranus and Neptune. If you ever spend a day with Jupiter or Saturn, they're very gassy.
But exoplanets that are that size tend to be called Neptune-sized planets.
Neptune-sized planets. And there are a bunch of those, too. Yeah. That actually turned out to be a bigger chunk of the population of exoplanets that have been observed than was expected as well.
Yeah, there's sort of this range between when it goes from a super-Earth to a Neptune, things like that. I don't know.
It's all very, of course, arbitrary dividing lines.
Well,
but in some sense.
But for the Neptune-sized ones, I think there actually is a little peak in the distribution of the number of planets. That it's not just like with asteroids in our solar system. There's, just as you get to smaller and smaller sizes, there are more and more and more of them. So you take any size, there's a certain number, you go to half that size, there's going to be 8 times as many.
Right.
And for the planets that we've seen, even correcting for the fact that the way we see them has certain biases in terms of how we detect them, they don't. They seem to have some clumpings or distributions or preferences in size.
Cool.
Yeah. So. Forbidden planet found by astronomers in Neptune-y desert is the new story.
Ooh.
A planet.
Neptune-y desert sounds awesome.
Neptune-y desert. It does.
Not to be confused with a desert on Neptune.
No, but it sounds like a good place for a sci-fi novel setting.
Yeah.
Maybe Bob could go to the Neptune-y desert.
Bob, the replicant from We Are Bob. Mm-hmm. We're going to come back to Bob a little bit. In the trivia.
Oh.
Boy.
So this planet, NGTS 4b.
So that's so NGTS, so usually the exoplanets, those first sets of letters refer to what survey or technique or whatever was used to find the planet. So, like, there's Spitzer dash blah, blah, blah. Oh, Spitzer's being retired. There was an article about that recently.
Spitzer is an infrared space telescope.
And it's been used to find a lot of exoplanets.
And unlike the Hubble Space... So, tangent alert.
Yeah, sorry.
Dear listener. Unlike the Hubble Space Telescope, which looks in visible and ultraviolet parts of the spectrum, Spitzer looks in the infrared and warm things that are just sort of warm by our standards, like your body radiates in the infrared. So infrared telescopes have to have coolant, and coolant warms up and boils away. So those telescopes have a shorter or limited lifetime.
Yeah, and most of Spitzer's coolant ran out a long time ago, so they've just been using a few of the wavelengths, like the longer wavelengths, shorter wavelengths recently.
Shorter.
They've been using longer wavelengths, less infrared-y.
Yes, yeah. So they get a few data points, but they're like
they
were looking for more funding for it, and so now it's sort of done.
End tangent alert.
Great, back on topic.
So NGTS 4b
is the next
generation transit survey,
and it's using some telescopes in Chile. No, the Canaries.
Ground-based telescopes.
Yeah. Carnal in
Earth-based
Chile.
telescopes, which is considerably more challenging than space-based telescopes. A lot of
but they're in Chile.
But you can have ginormous mirrors.
You can have ginormous mirrors, but you have also the Earth's atmosphere getting in the way.
It's in the Chile desert. It's in.
So this planet is 3 times the size of the Earth, 20% smaller than Neptune. Okay. If you work out that equation, that means Neptune is 4 times the size of the Earth. It is 20 times the mass of the Earth, which is reasonably close to the mass of Neptune, actually.
It's also reasonably close to, like, the sizes, potentially, of the cores of, like,
Jupiter and Saturn. Right.
We think that they have maybe more solid cores that are roughly 10 to 20 Earth masses or something.
Right, up to that.
So what makes this bad boy so forbidden?
Because it is super close to its star.
So because it's forbidden.
There's the appeal of the forbidden planet.
Why so badly?
It's in the forbidden desert.
Hotter than Mercury with a surface temperature of 1,800 degrees Fahrenheit. It orbits its star in 1.3 days, 1.3 Earth days.
It's pretty fast.
30 hours or so.
So it's in the same sort of radius as a lot of these hot Jupiters.
Right, but it's significantly smaller than a hot Jupiter. Mm-hmm. It apparently has an atmosphere.
Yeah.
But
And that's the real humdinger, right? Because it shouldn't have, when you're that close to a star,
And you're that small,
it's
relatively.
the heat and the starlight tend to want to not boil off, but strip away your atmosphere.
right.
And you can keep it if you are hefty enough, if you have enough gravity. But this thing
Doesn't have a ginormous amount of gravity.
It's not strong enough. It shouldn't have an atmosphere. It shouldn't be there. So what does that mean? That means
It hasn't been there very long.
It hasn't been there very long, right? So that it just moved in there.
And very long in astronomer parlance, in this case, means 1 million years or so.
Yeah.
Yeah.
Means not very long. Yeah.
Yeah.
Right.
So we're seeing a planet in the process of getting torn apart, or at least its atmosphere getting ripped apart.
Right.
And that's one of the interesting things, right, is a lot of times in astronomy we try to say, oh, something we're observing isn't special. This is a thing that happens all the time. But this is sort of a specialized moment in time to be catching this planet in there, maybe. Like, it's a relatively short amount of time.
Right.
And so it's pretty cool. But now I guess astronomers will look for more of these.
Right. Let me drop our trivia on you
Okay.
because it's related to that story.
All right.
Okay.
It's Forbidden,
We're ready.
Forbidden Planet.
Aha.
I'm titillated.
Classic science fiction movie, 1956. Laid the stage for sort of serious and, not super cheesy science fiction movies. Starring, famously, Robbie the Robot. In The Forbidden Planet, it became an iconic robotic figure. If you see pictures of it, you recognize a big glass dome with a couple of funny circular antenna going off. Friendly robot. I said we were going to come back to Bob. This is not Bob, it's Robbie.
Close.
The physical prop, or parts of the prop of Robbie the Robot, which was an expensive prop for that time, and especially for science fiction movies, which at that time typically had pretty small budgets. That prop was used extensively on many shows over the course of the next few decades, including science fiction shows such as Lost in Space. It's not the same robot as the robot in Lost in Space, but it was a guest starred in an episode of Lost in Space where it had a fight with the Lost in Space robot. It played a bad robot there. It was in several episodes of The Twilight Zone, also in some weird shows, which I would now very curious to go back and see how this thing appeared in them, like Columbo, the detective show, and a sitcom from the 60s called The Gale Storm Show. But our trivia question has
Now
to
I want
do...
to find that episode of Columbo.
Yeah, I know. Our trivia question has to do with its appearance in an episode of the second season of Mork and Mindy.
Oh, yes.
Starring
Filmed
Robin...
in Boulder.
The house is
The
at
house
least
is
in
in
Boulder.
Boulder.
Starring Robin Williams and Pam Dauber. The robot appeared in an episode called Dr. Morkenstein and played a character called Chuck.
As one
And the
does.
trivia question is, who supplied the voice of the robot on that guest starring episode of Mork
That
and Mindy?
is significantly trivial.
Yeah.
That is why I'm going to give you multiple choice.
Okay.
Even so. That
Is it a different person
is
that
a
did it the rest of the time?
minute bit of trivia.
It's Forbidden Planet trivia.
It's perfect.
Okay.
Perfect.
Go for it.
We're totally going to guess something.
Yeah, we're gonna get it. We have a 20% chance of getting it right.
You do. Maybe better. Your choices are, I'm going to give you the names of, so the
I don't know why this is funny.
It's funny because I'm realizing how
Ridiculous this
ridiculously
question
trivial
is.
this question is.
Yeah.
But
I like how you didn't realize it before, or even when Jim said it. Only when
Well-
you started to read the answers.
that's right. Well, because there, when I was coming up with it, I was like, well, how nobody would ever know this. But one of the reasons it's interesting, fascinating,
It's not.
is that well, by definition, it isn't because it's trivia.
Ah, okay.
Okay, it's trivial.
Okay.
It's supposed to be unimportant.
Okay, what are
It's
the options?
unfreaking important.
What are
Okay.
the options?
The interesting thing is that the person who voiced it in this episode, the person you're looking for, also voiced another robot in something else.
Oh.
Okay.
So I'm going to give you the other robots that were voiced. I'm going to give you 5 other robot voices.
Okay. Okay.
Great.
And the
That
person
sounds perfect.
and the person who did them, if you want. Do you want me to give you the person who did them, or just the
No, we
robots?
won't know those names.
Yes, you will.
Oh, okay.
You'll know some
Give
of them,
us
but
all
you
of
don't
it.
need to. you want just the robots or the robots and the actors?
Robots and the actors. Go.
All right. HAL 9000 from 2001, voiced by Douglas Rain, who, by the way, also did The Evil Computer and Other Robots in Woody Allen's Sleeper.
Oh.
So there's a whole market out. There's a whole job opportunity to be the voice actor of robots in science fiction.
All right. I'll give it my 2 weeks.
Probably all men?
The person...
Almost all men?
Well, this is going back to the 60s and 70s.
Okay.
Yes, but we have more... I think we...
Rosie in the Jetsons.
There you go.
She was a robot.
Robbie in The Forbidden Planet. So, in other words, the same person who did it in the movie.
Okay.
His name is Marvin Miller.
Okay.
The person who did the robot called B9, which I didn't know that was his name, in Lost in Space TV show, Richard Tufeld. The original
Not the new Lost in
60s,
Space?
Original 60s Lost in Space TV show, B9 robot voice. Vincent from The Black Hole, voiced by Roddy McDowell.
Oh, yeah. That was previous trivia question.
It was.
or something.
And coming back to our last episode, all about Bob, old Bob in The Black Hole, voiced by Slim Pickens.
That's the best name ever.
I kid you not. So, okay.
Okay.
Those are your choices.
Okay.
Yep.
Very
Those
important.
are our choices.
Very important trivia.
We're definitely
We
going to
have it-
guess one of them.
So before you get to the answer,
Yep.
let's talk about the other exoplanet discovery,
Great.
which was a new algorithm used to tease out the signal of transiting exoplanets from Kepler data, Kepler being the space telescope that's observed so many thousands of exoplanets. And they've discovered 18 new objects that in the story they're calling Earth-sized exoplanets. And I think that somehow it has become the sort of common parlance to say if you're up to 2 times the size of the Earth, you are Earth-sized. And if you're bigger than that, then I guess you're Neptune-sized, which is
Okay.
4 times the size of the Earth.
It's reasonable.
So these are, I don't know, the biggest one is a little bit less than 2 times the size of the Earth. And that increases our number of so-called Earth-sized exoplanets significantly. Unfortunately, most of them are in this sort of same miserable places
Right.
of either excruciatingly hot or deathly cold. Part of the reason, so the hottest one of these is up to 1,000 degrees Celsius, which is, what is that, 1,400 degrees Fahrenheit or something, so far hotter than Venus or Mercury, for
Right.
that matter. And part of the reason that, so I tend to be a little bit grumpy about the exo Earths because I don't really consider any of them to be very Earth-like.
Well, in conditions, you mean?
Yes.
But in size, they are.
Some of them in size are.
But a lot of
They're
the
relatively
Neptunes
small
aren't
numbers.
necessarily
Baby steps
Neptune-like
here. Before we can
conditions.
find an absolutely perfect Earth analogy, you got to find some planets that are Earth-sized.
Well,
Then you got to find the ones like that are in the.
Do they call them Earth-sized or Earth-like?
Earth-sized.
Okay. 'Cause there are a
18
few we say that are Earth-like. There's very few
Yeah.
that have been in that category.
Right. Part of the problem is I'm grumpy somewhat unjustly because most of these are around smaller, cooler stars than the sun, which means that the distance where temperatures are nice is a really narrow range.
Right.
It's like if you're next to a gigantic fire, there's this, you can walk around up to a certain distance from it and significantly farther away from it and still be comfortably warm. But if it's a little tiny fire and you want to keep yourself warm, there's just like one spot where it's just right. And it's the
Right.
same with planets around other stars. If the star is a little dim star, there's like this narrow window
Right.
of loveliness, and closer than that, you're burning up, and farther away, you're just a frozen.
Right.
So how do
this
you
catch
want them-
22 because those are the stars that are out there. They're
Yeah.
Those are the
way
easy
more
ones.
little stars
Yeah.
than big stars, even though it may be for bigger stars
Yeah.
easier to get.
But-
Not exactly catch-22, but it is
no,
a problem.
No, not catch 22.
Yeah.
Well, but so what are you mad about?
I'm just mad at the. I'm just generally mad.
Yeah.
Generally
In this case-
grumpy. In this particular case, it's the overselling the similarity to Earth, I think. I think that's a little bit of the
What do you
boy
want them to
crying
call
wolf.
it then? How should they describe it? Venus-sized?
Sure, actually, I would prefer that. It's as accurate in terms of the size. And then they could also call them Venus-like, although I don't know about that. That would require a big, thick atmosphere, so we don't know for sure about that for many of these.
I think cool part. Oh, I was going to say. I think a cool part about this article that we're discussing, or this finding, is not really what they found, but
how they found
it. I think a lot of people don't. It's not easy to figure out how they find these things, because it's not like we just go out and take pictures of the sky and see new planets. Right? I mean, we can do that occasionally.
Yeah.
But for the most part, you're teasing this information out. This transit thing is, the planet crosses in front of the star, causes the star to dim, but by this ridiculously small amount, by like
fraction of a percent,
0.2% dimming or something. But there are lots of reasons the stars could dim by 0.2% or something like that. Mm-hmm. And so figuring out that that's a planet digging and then again,
figuring out anything about the planet.
Yeah, figuring out, because you got to figure out these orbital properties and so forth,
and how big it is, and whether or not it's got an atmosphere.
Doing all of this
from these little tiny variations in that star's
That's
brightness.
right, and even finding the variations is ridiculous, because the
noise.
There's naturally noisy data, and it's very difficult to dig these things out. So the actual work of a day-to-day work of an astronomer doing this kind of thing is just poring over code and data and trying desperately to dig out some kind of signal. From this a huge amount of noise, and that's a really challenging job. And so this, even though that's not the part that the public cares about, that's the really interesting and challenging part for astronomers.
An important part for these new discoveries, because both of them involve doing exactly what you described, pulling out very weak signals and using new data analysis techniques. And the fact that they're able to do that means that now those techniques can be applied to all the new data that's being collected by TESS, NGTS, so that we will be able to discover even more things.
Right.
So
awesome. Good
I'm
job,
not
guys.
not grumpy about that. Not grumpy
great.
about the work.
Right.
Yeah. All right. Do you want to take a crack at your trivia, and then we'll touch base on matter, antimatter?
I'd love to.
Sure.
Okay. Do you want me to
Just
reread the entire
give us the
setup?
robots again.
Give us
just
the
give
robots.
No, I'm going to give the whole setup again.
Great.
Have either of you seen the Forbidden Planet?
I don't think I
I've
have.
seen clips of
It's
it, but
on
I've never
Amazon
seen the
Prime.
whole thing. All right.
So you can stream it. It's a classic.
I've heard of it. I
And
think I've seen clips.
It's a little bit. I mean, like those stories are pretty cool. I think some of these things, but it's hard to watch sometimes. Science fiction from the '60s or something like that. Cause the effects are so bad compared to. I mean, understandably, it's not.
Yeah.
But it can be hard to watch. It's campy and everything.
Right.
But we'll give it a shot.
Give it a shot.
The movie poster for the Forbidden Planet shows Robbie the robot carrying a sort of bikini-clad damsel in distress or something like that.
As one does.
You've hooked me.
That is not in the movie.
No.
It has nothing to do. It sort of makes it look like there's this evil space robot kidnapping lovely Earth women
to lure you in.
to lure you in, but the robot is just a friendly member of the crew and doesn't have anything to do with. So, okay, your choices are the person who did the voice of Hal in 2001, the same person who did the voice of this robot in The Forbidden Planet.
What was the question? I thought it was.
The question is who voiced him when he was on Mork and Mindy.
Yeah.
Who voiced the robot on Mork and Mindy?
Yeah.
Is it the same guy who voiced him in The Forbidden Planet 20 years earlier?
You wouldn't do that. This can't be that one. All right, go ahead.
Okay.
Is it the person who voiced the robot in the Lost in Space series?
Okay.
Is it the person who voiced the robot Vincent in The Black Hole? Or is it the robot who voiced the robot Bob in The Black Hole? Those are your choices. Let's hear your answers.
Addie, you got to guess?
I'm going to go with same dude.
Same dude.
You think
Same
he's
dude
really,
from
you
The
think
Forbidden
he's
Planet.
Sure.
playing psychological games with us? I'm going to say it's the guy who voiced Bob.
The guy, Slim Pickens.
Slim Pickens.
Actually, Jim,
Roddy McDowall.
it was Roddy
I was gonna
McDowell
go with that.
who voiced Vincent, who was the answer to your equally obscure
Yes.
Roddy
Yes.
McDowell answered
That's true.
trivia question
That's
from
very obscure question.
from several episodes ago.
Yeah.
Now, I cannot, on our last episode, all about Bob, we had Dennis Taylor, author of the We Are Bob series of books, available everywhere books are sold. Check it out.
And on e-readers or audiobooks.
Audiobooks as well.
Jim.
We mentioned the Bob robot from the black hole, which has this. Do you remember what that stands for? It's one of
It
the
was
worst
some
acronyms
ridiculous
ever.
thing, yeah.
The Biosanitation Battalion.
That's right.
How anybody came up with that is beyond me. That's the Bob. All right, so Vincent was voiced by Roddy McDowell. That's V.I.N. Cent. C-E-N-T. So there's no dots in the cent part, but there are for the V-I-N.
Okay.
Any ideas? If you get any of that right,
Give us a
I
tiny
will
bit
give.
of context.
That's the name of a robot in the black hole, voiced by
Okay.
Roddy McDowell.
Okay.
It's
Virtual.
Interactive.
Incorrect.
Neural.
Incorrect.
Okay.
And he guesses for the C-E-N-T.
He's like,
Centurion.
oh yeah.
All of these, by the way, would be far much better than what it actually is.
Viable.
Also better.
Very
Here it is.
intelligent.
No.
Natural.
That's pretty good.
Centaur.
The only one of these that's any good at all in the real thing is the I. So
Okay.
Vincent stood for
Yes.
vital,
Okay.
information,
Okay.
necessary,
Oh.
centralized. I kid you not. That's
Vital
not even a thing.
information, like network, maybe.
Vital information necessary, centralized.
Perfect.
Very good.
Vincent.
They need to take some NASA acronyms.
It's worse. That's even. Which is worse, that or Biosanitation Battalion?
Yes.
I don't like the biosanitation
that-
I
battalion
don't
because you can't just take random letters from
You
the middle
can.
of the word.
You can.
You can take a few from the beginning, like if you wanted to keep the B-I-O, but you can't
You
take
have to
the
keep
B.
the S. If you're taking the O, you have to take the S.
Why?
You can't just take the O. You have to keep the I.
Biosanitation is one word, right?
You're
I
not
don't
allowed
know.
to just take random letters from the middle of the word.
You are. I've done it.
Oh my. Oh,
I usually
boy.
don't. I usually don't.
Now
I
we're
usually take
all-
like
now
the first
we're all
two.
mad.
We're all grumpy
Everybody's
now.
grumpy.
All
I
right.
usually
Well,
take like the first two.
to calm us down, tell us about the latest matter-antimatter news.
So matter and antimatter, very cool stuff. Antimatter is everybody's favorite science fiction way to power your starship or whatever.
I wish I don't remember how old I was when I learned that antimatter was not a made-up thing in Star Trek.
Oh, I know.
Because I,
It's amazing.
as a kid, assumed it was a made-up thing. It sounds like a made-up thing.
It does absolutely sound like a made-up thing, but it's totally real. And I'm sure I've told my story before on here about the book that I wrote about antimatter. So
You wrote a
that
book
for-
about antimatter?
Yeah, but I'll save it for
A science
another-
fiction novel?
No, not a whole novel. It's more like a short story.
Oh.
What's
it
it
was
called?
awesome.
What's it called?
I can't remember what it's called. But
You
here's-
can't
publish
remember
it?
what
Can
your
we publish
own
it?
story
Here's
is
how
called?
it went. I think I've told this on the podcast before, but if so, it's been a little while.
Even we don't remember it, Jim.
Yeah, it's been a while. The basic premise was this. So antimatter, one of the awesome things about it is how do you keep it? You get some. How do you keep it? What do you have to do?
Put it in your pocket.
Can't put it in a
Magnetic
little box
field.
because a box is made of
Matter.
And of course
just,
the air
just
is
like
made
in,
of
just
matter.
like in Star Trek, matter and antimatter annihilate.
That's
on
right.
contact.
This was back in like early high school, so it was ninth grade or something. I found out about this antimatter stuff,
5
and I was
years
like,
ago.
all right. You'd use little magnetic fields to keep it. Anyway, that's not important to the story. So anyway, you get little bit of antimatter, and here's the thing: like 1 gram or 2 grams of antimatter, that's enough to totally annihilate an entire city, right? Because
Yes.
because you just combine that with matter, all of it is annihilated and becomes energy in the
A
form
huge
of
amount of
gamma
energy.
rays and all, So a huge amount of energy. So you can just a little gram, like a paperclip's worth of antimatter. That's a whole city annihilated. So in the book, there was a bad person. For some reason, it was me in the book. I don't know. I was like evil.
Interesting.
And I masqueraded as a medical doctor.
Okay.
And went around and was doing surgeries. And I would like take people's appendixes out and put in an antimatter blob, little pill with a
in its own little
And it's-
magnetic
in a little
containment
magnetic
device.
Contained.
and I had a little remote control to turn off.
Isn't that in?
Boy,
This is very similar.
Isn't that
You're
in
noticing this is similar
Angels
to
and Demons?
Angels and Demons.
Yeah.
That son of a gun ripped me off. I wrote this before Angels and Demons.
Oh.
I didn't know that happened.
No, he didn't actually write me off because this wasn't published.
Yeah.
Yeah.
Except maybe in our.
Maybe
high
he
school
broke
thing
into
or
your
whatever.
house.
Maybe he read your high school.
This is very upsetting. But anyway,
publications.
they did it differently there.
Yeah.
But it was also a plot point, But anyway,
Yeah.
so I went around to like 800 different people around the world, and they had these things in. And I took the world ransom, or held the world ransom for this, and then and I blew up a few cities.
I like
and
how
then
it's you.
eventually-
I like how it's you in the
Yeah,
story.
it was me. I don't know why. I'm not evil. I don't want to kill anybody. But then there was a good guy, some kind of police And they eventually hunted me down and killed me. But then I had the last laugh because when I died, all of the...
they all went
they
off.
all went off.
And, well... then you had the last laugh. I love how you explain it that way. It's like, I was dead and the world was destroyed, so I guess I win after all.
No, it wasn't me. Anyway.
It was, though.
That was going to be a tangent. I apologize. One really big question we've had in astronomy for a long time, and cosmology and nature of the universe, is why is the universe made of matter and not antimatter? Right? When you have matter and antimatter, it combines and annihilates, and you just get energy. And we think in the very, very, very early universe that there should have been equal amounts of matter and antimatter produced.
In which case, it all would have annihilated.
It all would have annihilated very early on in the universe, and the universe would just filled with energy and not stuff. But clearly, there was some kind of little bit of
imbalance.
Slightly more matter than antimatter, but very slightly, like 1 part in a trillion or something like that, difference in the amount of one and the other. Most of it got annihilated energy, but the little bit of remaining stuff is the stuff that we're made of today.
And just for basics, the difference, and I'm sure there's more than this, but my very basic level understanding, the difference between matter and antimatter is an antimatter particle is the same as a matter particle, but with the opposite charge.
That's right. So there's like an electron, right, is the thing. There's an anti-electron, which is often called
positron.
A positron, which has the same properties, same mass, same spin, all that kind of stuff as a electron, except it is positively charged instead of negatively charged.
Yeah. So by itself, it's not anything spooky or exotic.
No, it's not too crazy, except that when it meets an electron,
right?
Bad news bears.
Bad news.
Yeah.
Luckily, there's not a huge number of positrons running around out there, right? You can make them in particle accelerators, and they're made from radioactive decay, and cosmic rays hit our atmosphere and produce them occasionally, but in tiny, tiny, tiny amounts. So we've been doing experiments to try and figure out maybe why there's this asymmetry between matter and antimatter. And we won't belabor it, but basically we haven't figured out why there's more matter than antimatter.
There's no answer.
There's no answer just yet.
The new news has to do with some results out of the Large Hadron Collider in Switzerland, where they found an asymmetry... Hadron. Oh, good grief. God. You said try-and. I'm going to say hadron.
So does everyone else in the world.
Whatever. I know. It's infuriating. I'm grumpy about that, too. The new results from the LHC found an asymmetry in the charm quark, I believe.
What?
Yes.
Like a difference in how charm and anti-charm quarks
decay, the rates at which they decay.
Right. I
so,
hope
for
I never
example,
meet anti-charm.
you could make the same...
Yeah, you're in trouble.
That's true. We will not have anti-charm on the show.
You can call in.
I think in principle, if the universe had been created with equal amounts of matter and antimatter, but there was some process by which antimatter decayed at a significantly faster rate than the matter, then you would end up with an imbalance. Even if you started with the same amounts before it all annihilated each other, you'd lose enough of one to have some left over.
But it doesn't look like...
An imbalance has been seen for 3 different flavors of quark, but so far those imbalances that I've been seeing are too small to explain the amount of matter that we've got in the universe.
Right. So still an open question. Go figure it out, guys.
Interesting.
And girls.
And girls. I apologize.
You're fine. I knew you meant generic.
Yeah.
While it may have felt like a journey to the Forbidden Planet, it was just another episode of Walkabout the Galaxy. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. We're also on YouTube at Walkabout the Galaxy. There's a theme there.
Interesting, yeah.
Where you can see why this really should just be an audio-only podcast.
Hey!
Thanks to our listeners in Ontario, Canada, and around the world. Follow us on Twitter.
At walk_the_galaxy.
Where you can ask us questions and suggest topics that you'd like to hear us discuss. Our theme music was composed by Richard Jerusik. Our production assistant and video guru is Guru. Our video guru is Diego Rodriguez. Catch up on old episodes wherever you get your podcasts and write us a review in the background lettering on the set pieces of the next Star Trek movie. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.